Have you ever wondered why elements behave differently as you move across the periodic table? Why does sodium react explosively with water, while argon doesn't react at all? Today we are going to understand the periodic trends. First let's talk about the atomic radius. The atomic radius is the distance from the center of an atom's nucleus to the outermost electron. As we move from left to right across a period, the atomic radius decreases. This happens because as we add more protons and electrons, the increased nuclear charge pulls the electron closer to the nucleus, making the atom smaller. On the other hand, as we move down a group, the atomic radius increases because new electron shells are added, making the atom larger. For example, compare sodium on the far left of period 3 to chlorine on the far right. Chlorine is significantly smaller. On the other hand, if you compare lithium at the top of group 1 to cesium at the bottom, cesium has much larger atomic size due to its additional electron cells. Does atomic radius increase as we move down a group? Now let's explore ionization energy. Ionization energy is the amount of energy required to remove an electron from an atom. As we move across a period from left to right, ionization energy increases. This is because the atoms are smaller and electrons are held more tightly by the nucleus. As we move down a group, ionization energy decreases because the electrons would be further from the nucleus and are easier to move. For instance, it's much harder to remove an electron from neon than from sodium. Now let's discuss electron affinity. Electron affinity is the energy change that occurs when an atom gains an electron. Generally, as we move across a period, electron affinity becomes more negative, meaning the atom readily accepts an electron. This trend isn't as consistent as others, but it generally holds true for most elements. Moving down a group, electron affinity becomes less negative as the added electrons would be further from the nucleus and thus less attracted to it. For example, fluorine has high electronic affinity because it needs only one more electron to complete its valence shell. Elements like noble gases don't follow this trend because they already have a complete valence shell and don't need to gain electrons. Lastly, we have electronegativity, which is a measure of an atom's ability to attract and bond with electrons. Electronegativity increases as we move across a period from left to right because atoms are smaller and more eager to attract electrons to complete their outer shell. Conversely, as we move down a group, electronegativity decreases because the atoms are larger and the bonding electrons are further from the nucleus, reducing the attraction. For example, fluorine is the most electronegative element because it strongly attracts electron to complete its valence shell. If you have any questions or topics you would like me to cover, drop them in the comments below. Don't forget to like, share and subscribe.